Well, hello everyone. Welcome to this session in Sonada. I'm Ravi Agrawal, the editor-in-chief of Foreign Policy magazine, and it's a real pleasure to be your host for the next 45 minutes. I also want to welcome our viewers from around the world who are watching this session on live stream on WEF's website and also on FP Live. So welcome to our viewers around the world, and to you here in this room. I would love to draw on your wisdom as well, so I'll come to you for questions towards the end of this session. If you have something, make eye contact with me, raise your hands, and I will bring you in. So, our session title today is Twinning Energy with Digital, and I believe this is the first time that WEF has paired these two issues together. The question is why and why now? And I think there's a very simple answer to that. The energy industry alone is responsible for a third of all global emissions. According to the WEF, by 2050, if with purely digital technologies that are available to us right now, if we use those technologies in the right way, we could reduce emissions by 8%. So that's the clear potential without further innovation. And that's why these two issues together are so important. But then the question is, why is adoption of these technologies as slow as it is? What are the hurdles? What do we need to do to overcome those hurdles? And what lessons can we learn from companies and countries around the world? So those are all of the questions we're going to dive into today. And to do that, let me bring in my excellent panel. I'm going to ask you to hold your applause until I've introduced all four of them. So to my left and onwards, I have Pekka Lundmark. He is the president and CEO of Nokia. To his left, I have Jean-Pascal Tricoire. He is the chairman and chief executive officer of Schneider Electric. To his left, I have Katharina Beumelburg. She's the chief strategy and sustainability officer at SLB. And to her left, finally, I have Christoph Schweizer. He is the chief executive officer of Boston Consulting Group, BCG. So, Christoph, let me start with you. Given that the energy industry is responsible for a third of all global emissions, I'm curious about your take, given all of the clients you have all over the world, about how much of those emissions, how much of that is because of inefficiencies in the system. And the reason why I ask this question is I want to just frame this and make clear, given how much those inefficiencies are there, how much room we have to fix them.
Well, you just quoted the numbers that have been published by the WEF, right? I do think there's a meaningful amount of inefficiency out there, but then there's more than that. I mean, that's a kind of current snapshot of where the world stands. If you think beyond that, we are now at this moment where the energy transition needs to happen, and it's starting to happen in many parts of the world. And look, there's a very simple correlation between digital and the future of energy. There will not be a successful energy transition without digital technologies, and in particular also AI being deployed at scale and highly effectively across everything that happens in renewable energy, but also in the more traditional part of the value chain. So is there inefficiency today? Absolutely. But I think the bigger question is, where are we going, and how can we make that happen with meaningful efficiency in the investments at the right pace? I mean, it has to be faster than it is today, and how can we also get the workforce into place to actually pull it off? And I do think you need digital at every part of that transition, and so I think the topic is very timely.
And just very quickly, when you are approached by clients around the world, how high up on the agenda is this issue for them?
I would say on average it's a top 3 issue. I mean, if you are in the energy industry, it's obviously one of the top 2 questions. But even for many industrial goods companies, consumer goods companies, even tech companies, the question comes up, how do we actually decarbonize and also secure our energy supply going forward? And despite all volatility in the world and disruption in the world, many boards, investors, CEOs, executive teams have that as a continued priority. There's always some urgency of the day, but fundamentally I think it's top of mind, and it will remain top of mind for many companies very systematically around the world.
Well, let's hope so. Katharina, let me bring you in. You work for SLB, formerly Schlumberger. You are the world's biggest offshore drilling company. And I have to ask, the word drilling and decarbonization, aren't those two words an oxymoron in the same sentence?
Honestly, Ravi, not at all. I think what I strongly believe in is that we need oil and gas for a comparably long time during the transition, because obviously we can only keep our standard of living and achieve the growth that our planet is hoping for with the amount of energy. And if you see how energy demand is growing, it is clear that for a comparably long time, oil and gas will be part of the game. Having that said, and being a strong advocate for reducing carbon emissions, this is why we really need to decarbonize the oil and gas industry. And there are lots of different ways to do that. There are the obvious ones like carbon capture and storage, and there are other very technology-driven ones. And we as a company really believe that we can achieve net zero, including scope 3, until 2050, and we have very tough targets for shorter timeframes. So it can be called out in the same sentence, and it works together.
And just to follow up on that, how much has digital technology enhanced efficiencies in your space?
See, Ravi, this entire topic of achieving net carbon zero, of driving emissions down, all of that is only possible with digital as an enabler. And it starts with bringing the transparency so that we actually know where in our operations the emissions are happening, at what time and how much. And then creating technology pathways to net carbon zero is something that is all done with digital enablement, and this is why it's so essential, and it will not happen without digital.
Pekka, let me bring you in. When I was chatting with one of your colleagues a few weeks ago, they mentioned something I was not expecting them to mention, which was the Metaverse. And apparently, the Metaverse could be used as a way through which to design new systems that are more efficient, that use digital in a better way to improve infrastructure. Can you speak about that?
Well, yes, the energy transition, first of all, is very much a connectivity challenge when the whole energy system is moving from a one-directional pipe from large generating units to passive consumers. It becomes a much more decentralized system where communications all the way to the small granularity of both production and or generation and consumption will be able to be accessed. It becomes a digital challenge, and Metaverse, even though the term is perhaps overhyped quite a lot, but it is actually a significant part of the answer, because there will be a time when we will see a digital twin of pretty much everything on the industrial side, and a lot of the things that are today tried and implemented directly in the physical world will be designed and tested and implemented first in the digital world, and that will have a potential to significantly reduce waste of the process, improve energy efficiency and sustainability of the industrial side of this equation. This is not only about power generation, electricity generation, or energy production in general. It's very much about industrial processes that we have to decarbonize.
Jean-Pascal, let me bring you in. You have a lot of business in the global south, in the developing world. And it occurs to me that as we're discussing a lot of these energy transitions in the West, those transitions may be very different from what the global south needs to go through, where it's difficult to sort of separate that from industrial policy, from building large-scale infrastructure that may not already be in place. How do you see that working? Is it an opportunity to leapfrog, to use a cliche, or is it a greater challenge for developing countries?
Look, it's a great question. First thing, when we speak about energy, to start with, the first duty we all have is to provide energy to 2 billion people on Earth who don't have access to reliable energy, because for all of us who've lived in emerging countries, when you don't have access to energy, you don't have a decent life. So energy is your passport to a decent life. Now we have also to reconcile that with the huge challenge of climate change and decarbonization. So it's not emerging countries, it's all countries which have to go through not an energy crisis, but a fundamental energy transition from carbonated to decarbonated. And you started by saying, rightly so, that the energy industry is responsible for 30% of the emissions. Let me correct that. Energy production and consumption are responsible for 80% of carbon emissions. Because what strikes me is that the world is speaking about energy only on the supply side. But if you look at the history of humanity, energy transitions happen because there is a transition on the demand side. Cars won't become electric because there was an excess of electricity. They will become electric because somebody in California made the first car at scale which would be usable on electric. So you look at the future of electricity. We focus on demand at Schneider. Look, the demand that we're going to have, it's very simple. It's going to be more electrical because it's the only way to decarbonize, and more digital to be more efficient. And at every step, digital is fundamental and absolutely crucial. You can disrupt efficiency by using digitization, smart homes, smart buildings, smart manufacturing, smart cities. The only way in the 21st century to disrupt that. Then when you go to green electrification, because electrification makes sense only if it's green, that means green electricity is volatile. So the only way to adjust demand and response, demand and supply, is to digitize on, like Pekka was saying, connect supply to the demand in real time. And then...
But can I push you on that just a little bit? Because the demand is there, isn't it? People want cleaner energy. They want more energy. As you pointed out, most people are underserved in that sense. So where are you seeing the demand issue here?
I just think we are just at the beginning of a transition, because those technologies, IoT, big data, IA, as we are speaking about, on electrification of cars to site, or heat pumps in buildings, which are going to substitute boilers, are just coming to maturity at the same time. So we need now to rethink everything we are doing, architecture, construction, usages, and transition that. And the supply will chase the demand. But we always start with supply. We should always start with demand. And now back to your initial question. The opportunity in emerging countries, in new economies, is to build sustainable from the beginning, to build decentralized from the beginning, to build renewable from the beginning. So this is where we can really leapfrog in new economies with respect to what.
The question there is financing. I'll come back to you about that. But Pekka, you wanted to jump in.
Yeah, I mean, just to comment, build on what Jean-Pascal said, the demand side will actually go through a significant revolution, because if and when we want to maximize our decarbonization, it means that we have to electrify significant industrial processes like steel making. Decarbonized steel will be a significant consumer of electricity. We need to electrify significant parts of our transportation system. We need to electrify our heating system, which is actually in many places 2/3 of the total energy consumption. This is not going to be possible without significant digitalization of the entire energy system, including for the reason that Jean-Pascal just mentioned, that when we are providing more and more weather-dependent intermittent electricity, maintaining the stability of the system in a situation where there is high demand becomes an increasingly challenging technical challenge to maintain the inertia of the system, maintain the frequency and stability of the whole grid. It is a digital challenge in addition to just adding more and more renewables.
You know, so in discussions like this, we often lean into problems, and I want to try and lean into solutions for a few minutes. Christoph, if I can come to you, again, given the work you do around the world, given what you see through your clients, are there some examples of how digital and energy transformations would twin together in a way that the rest of the world can learn from?
Yeah, I do think there are plenty of examples and very exciting ones. And in fact, if you look at kind of how renewable energy capacity is being built around the world, I mean, you can go through any part of that cycle. The initial kind of site selection where you put a wind park or a solar park, then the actual project management and installation, then the kind of going into service and operating it, maintaining it, the grid management, Pekka, that you mentioned afterwards. You can go along that entire value chain and you find absolutely fascinating examples how digital can make this faster, cheaper, better. And just to pick a few examples, I mean, you can today look at the best sites for wind and solar installations using geoanalytics data, and it's just mind-boggling how fast it is compared to how it was done 5-10 years ago. And we just had an example for a US utility company where within a few months we found sites, incredibly attractive sites for 15 gigawatts of renewable installations. Yeah, normally that's something where departments in companies would have taken years to travel around, look at this, look at that. I mean, you take so much time out of it. You then come to the whole installation and project management. And Pekka, you used the kind of the digital twin analogy. I mean, how you simulate that build and the kind of material flow, the supply chain, the HR planning around it. I mean, you can build these 30 to 40% faster if you use the most modern and innovative and to some extent AI-driven tools. You then come into the actual operation. And look, renewable energy, in particular wind and solar, still are to some extent weather dependent, right? It's becoming a bit less so, but still they are and they will be. How you correlate data on weather forecasts with kind of availability of these sources and how you anticipate the demand management that you need to do, coming back to the theme you just had. I do think these tools are absolutely fascinating, and we see it being deployed to some extent in the Western world for our US utility clients, for our European utility clients, for industrial clients. But it's really fascinating to see how much the emerging markets, the global south, whatever you want to call it, actually use these tools as well, and to some extent even more creatively so. And for us, this is a massive opportunity, and I gain a lot of optimism from that, Ravi. I mean, you asked the question, why is everything so slow? We keep talking about it. Why isn't it faster? I do think it's picking up pace.
So maybe, Jean-Pascal, I'll come to you with this. What are the hurdles towards accelerating some of the pickup of what Christoph was describing?
Look, let's first realize the opportunity. For the first time, because of digital, in a system which was massively inefficient, everything is connected from the plant to the plug. Think about electric cars. They're going to multiply on the roads. You can mobilize, thanks to digital, the batteries of those cars during the day to charge when electricity will be cheap, green, and then restitute it when it's... So there is an amazing array of opportunities to change the old view on the old way we are using energy, electricity, and consuming it. What are the hurdles? We need to have data open and available between the utility, between your home, between the building, between smart, so that we can share, right? And it's not simple data. It's data which is contextualized. You know that if this machine is consuming, that's because this supply is coming up. So this all exists. Pekka is speaking about the metaverse. Come to Schneider. You can, on one cloud platform, design your factory, build your factory, and gain 30 to 40% on the construction, and then give augmented reality goggles to your operators that will be helped on safety. So first thing I think is adoption of technology. We human beings tend to take a long time to adopt technology. Think about the internet. Appeared in 95. How much time did it take for Uber to appear? So sure. We have to go faster. Workforce. We don't have trained people able to go on the field to mix digital and energy. We need to train thousands of people for deployment. Price signals. Take the example of Europe. The government had no choice but to soothe the pain of the consumer by putting 600 billion of subsidies to pay for the overcost of gas on oil. Think about that money invested into making homes and buildings net zero, for the future and being not needing supply of oil and gas for the next coming years. So these are all the things that we need to put together so that we want to execute faster. But to be optimistic, our activity in that business is growing solid double-digit for the past many years. So we have plenty of realization in every geography. And you speak about emerging economies. The biggest smart grid we are building today is in Egypt for 20 million families. So all of this is happening everywhere.
Wow. You know, we haven't talked about financing at all. I mean, it's easy, I think, to say, why didn't the internet take off faster? It's because there were infrastructural issues where people actually didn't have PCs or telephone lines. It took the smartphone for hundreds of millions of people in the developing world to finally get online. With energy as well, most of the world is energy underserved, which also makes it slower. And it strikes me then, as I describe this, that, again, we're dealing with some big infrastructural issues in many parts of the world that you almost need industrial policy to fix. Pekka, let me come to you. Is it your sense that multilateral financing is a big hurdle towards some of these changes?
Well, the amount of investment that is needed in this twin transition, energy and digital, it's obviously massive, and there is no way how that could be ever funded through public state budget. So the only possibility is that we create circumstances that attracts enough private investment, and that's where we get to the role of the public sector. It is to create a system where these investments are attractive investments. There is enough money, there is more than enough capital available in the world if we have the right incentives in place, and they should be market-driven incentives. My favorite example is the European emission trading system, which has been working very well. The authorities create a system where the emissions are capped. The cap goes down every year by a certain percentage, and then everybody who needs to emit CO2 needs to buy a certificate, and the market allocates the capital. In a perfect world, we would create something similar for the whole world, and that would actually make sure that enough capital would be allocated. This is a fascinating time to work for a communications technology company at the moment, because what we are now seeing that the energy industry has started to, and utilities have started to do, is to put in a significant investment in a new generation of communications networks, exactly for this reason that we discussed, because basically every element in the network that is connected to the energy network needs to be connected. So, conclusion, there is enough money, but what I'm worried about is that how do we make sure that we create market-based incentives, the right type of incentives for these investments?
So I want to run a quick survey. I'm going to ask all of you one question and ask you to give me a rating out of 1 to 10. The question is, how worried are you about deglobalization? On a scale of 1 to 10, with 1 being not at all worried, 10 being very worried. Give me a number. Pekka, I'll start with you and we'll go that way.
8.
8?
10.
10.
8.
8.
6.
6. Okay. One more question and we'll go the other way this time. How worried are you about US-China decoupling? Scale of 1 to 10 again, 10 being most worried.
8.
8.
6.
6.
It's the same question, no?
It's very similar. It's very similar, but not exactly the same.
I'm going to be 10.
Okay, wow.
7.
7, okay. And then I'll do one more, just because this is great to survey a bunch of CEOs. Just building on what we were discussing about financing, how much of a problem is access to financing for the issues we're discussing? Scale of 1 to 10, 1 being financing is not the problem, 10 being there's simply no money. Pekka, you've already suggested that.
3.
3, okay.
Yeah, it's 3.
Okay.
I'm a 3 too.
Wow.
Well, what can I say? 3.
All right. So Jean-Pascal, let me come to you. You're extremely worried about deglobalization and US-China decoupling. Explain why?
Globally, well, first as a human being, I think we've all benefited a lot from globalization, and we are all part of the same planet. And think about it, all the major challenges we are facing, climate change, pandemic, supply chains, whatever, they are all global. So you can't resolve them by bifurcating. That's number one. The second point is we are a technology company. And I believe that we are completely underestimating the interdependencies which are existing between our blocks, and especially between the US and China. And see how much traumatic the bifurcation with Russia has been, while Russia is a very important country, but still much smaller in terms of GDP than China and the US. And imagine which kind of earthquake would be pushing into the direction of bifurcation.
Christoph, you seem less worried. Cheer us up.
Well, in fact, I make the same argument that Jean-Pascal just made. I do think the reality is the world is very interconnected. I do think if you look at the kind of average political sentiment, there are many things on people's mind right now. One of them is inflation. And it's real, it's big, and none of the current leaders politically, as much as in business, have lived in a period of relatively stubborn high inflation for many years in a row. We don't know that problem. And I do think the more you decouple, deglobalize, the more it's going to have an impact on underlying cost and hence on inflation. And I do think that will change at least the weights in the political discourse everywhere in the world. Okay, how much do we actually have to gain from a decoupling versus how much is it going to actually backfire in terms of inflation, consumer sentiment, etc. And so I do think, I mean, over the coming years, my hope, that's the explanation for the 6, is that there will be some balancing. And with all political rhetoric ongoing, I believe there are going to be some very big important factors out there that might slow things down or maybe even calm them down.
Right, fascinating. Pekka, you want to jump in, and then I want to come to Katharina.
I mean, just to build on what Christoph was saying, that I mean, the interdependencies between China and the West are so enormous. I mean, everything we are touching, that we are consuming, has a foot in one of these regions, and we are completely depending on each other. So I think a much better term, which actually many also here have been using, is that it is important to build resilient supply chains, and you have to prepare for different types of scenarios, but decoupling, it's a completely unrealistic scenario. It will not happen because it will not be possible. I mean, of course, that discussion started after the Russian invasion of Ukraine, and when many companies like ourselves have pulled out from Russia. But this whole question between China and the West is 10x, 100x, 1000x compared to what we experienced with Russia.
Yeah, no, of course. I would just argue that the idea of decoupling with China began well before Russia's invasion of Ukraine. If you think of Robert Lighthizer in the Trump administration, has been making the intellectual case for this for years. Katharina, let me bring you in here, and I want to move back to twinning, energy, and digital. And just through your work and experience, what is the role of government here?
Yeah, actually, that's a very good point. I think the question that we have to solve thinking about digital and energy is with all the fragmented systems we have, if we want to move forward fast, that comes with some necessities. So currently, I think the digital systems in the energy arena are very fragmented. Data standards are not there. So it's very difficult to bring all of this together. And that, on the one hand side, is asking for private partnerships. So where companies and customers form partnerships, we just announced a partnership with Aramco for a sustainability platform, on a digital sustainability platform, where we are trying to overcome this. But I think this entire question of how data is shared and the value of shared data for driving the energy transition is something where governments have to form an opinion on, and the administration have to figure out what is more worth, so to say, the data as a value that is owned by somebody, or the greater good that can be achieved when you bring this data together. Because I think currently a lot of private sectors and administrative sectors are sitting on data, but they are not really used because they are not brought together. And I think that's something where we are in the process of shaping an opinion, but it's early stage. On the other hand side, if we want to be fast, that's a fundamental point.
In a few minutes, I'm going to come to you in the audience for your thoughts and questions. If any of you work in government, that would be a nice perspective to add as well. So raise your hands and I will come to you.
If I may add to your question,
please, yeah.
I think that evolution of the new world of energy will drive to a lot more decentralization. So yes. A lot of homes will be self-powered. A lot of buildings will have their own microgrid and provide 90% of their energy. We are providing today for customers industrial large campus, completely self-powered by microgrids. And that's a fantastic opportunity because traditionally the world of energy was centralized. Big companies, and energy was taken. But here, technology, digital, electrification combined together bring back the responsibility of decarbonization to all of us, and the capacity to progress to all of us. And in front of a very complex system, if you decentralize 30–40% of the system in the hands of responsible consumer, then you simplify enormously the task of governments, centralized companies, and so on. Provided we share data, which is really possible, that we can execute today. So it's a huge change, much beyond what we can imagine today.
Wow.
This is a good interactive moment in the conversation here. So there's one other area of public-private partnership which we haven't really spoken about, which I think is going to become top of mind very fast. So in a way, what you're hearing here is, I think we are generally relatively optimistic on the technology side. We are relatively optimistic on the financing side. The world will find its way around regulation and markets and all the vehicles you need there. I believe that we are not far away from a moment where workforce is going to become a constraining factor. And I mean, there was a study recently published by the IEA about kind of workforce needs in the kind of energy or green energy supply chain in manufacturing. And they predict that there are 6 million jobs today. By 2030, we will need 14 million people who manufacture all these solar panels and batteries, etc. So that's 8 million there. That does not yet include all the kind of installation, maintenance, operations, etc. So let's assume we talk about tens of millions of highly qualified people that actually do what this panel has as a label, twin, energy, and digital. And I do not see any country at the moment that is ready for that kind of workforce evolution that is necessary. So what does it take? I think it does take a very comprehensive partnership between public sector and private sector when it comes to changing the core education in schools, but then in college, in university, as much as in workforce upskilling, whether you already are in the energy space or in something else. I do think we talk about millions and millions of people who need to build all these solar facilities and who need to build that grid and the storage and all those things. And fundamentally, I think that's going to be the next stage of constraint. And I think that is really a great opportunity, but it's also an imperative for public-private collaboration.
Very quickly, and I'm going to put this question to our sort of the two of you, since you're Europe-based CEOs, with the Inflation Reduction Act in America, which essentially mobilizes $400 billion towards climate initiatives, but many in Europe see it as protectionism. They see it as unfair competition. They see it as the start of industrial policy, as a race/war between countries. How do you view that in the private sector, Pekka, if I can start with you?
Well, first of all, if I take a positive view to it, it is definitely a good thing that we allocate more capital to this transition. That's exactly what's happening now in the United States, and that is a very good thing. What we need to avoid, though, is in a way, a subsidy race between Europe and the US. And obviously, Europe will have to and will most likely respond.
And avoid why? Because it's inefficient?
No, because it would be really good if Europe, there would be transatlantic cooperation in designing this whole incentive system. And as I said earlier, it would be good to have as market-based mechanisms for this twin transition as possible, rather than there being a competition between kind of countries that who provides more subsidies. So that's why I think it would be really, really good that the European Union and the United States would find a common ground how they would approach this question.
Jean-Pascal, you agree?
Look, I see it as an acceleration of the transition. When you look at all equation we are talking about, you have the choice in paying every month a bill in energy which is far too high, on sending a lot of carbon in the atmosphere which is not needed, because the infrastructure you're building, your plant, is obsolescent, it's not done with the right technology. Clearly, there is a need in all places, all already built places, to move to the new model. The IRA is an incredible initiative to move to the model of tomorrow, and it benefits to companies like ours. We develop locally, we produce locally, and we serve locally. And I think it poses a question for the other regions of the world of, do we also choose to accelerate that transition from paying for OPEX of the past or building CAPEX of the future? So that's the way I see it. Then after, there are transatlantic relationship and diplomatic relationship that will settle on the economic side of that. But I see that as a well-needed acceleration, especially in the US, which is a brilliant country, but where the infrastructure was sometimes behind in many aspects. So time to move, they are moving and probably showing the way in accelerating the transition.
All right, excellent. Let me take some audience questions then. I see a hand over here. If we can get a mic over to the lady in the front row. Anyone else? Do I see other hands? If you can tell us your name, who you work with, and then your question, please.
Thank you very much. My name is Nonkululeko Nyembezi, Standard Bank Group in South Africa. Fascinating discussion. I'm not sure that I still understand the kind of real industrial logic, but I think we're getting in that direction. The question is perhaps more to Jean-Pascal and perhaps to some degree to Pekka. So for us to make real progress in going off-grid in the way that you describe for buildings and micro-type grids, battery storage needs to also now accelerate to industrial scale. Where I perceive batteries to have gone much further is for electric vehicles. But generally, people will drive their car to go into the office in the morning, park the car until the evening. So you've got this dead capacity sitting in a car when, in fact, you're needing it to hit a building during a part of the day. Can you maybe just talk to us about a future scenario where this can, using digital technology, can then be drawn into the system to shore up and give it that stability or inertia that you spoke about, at a time when people don't need the car, of course by consent, because all of this has got to be coordinated somehow. Is that a realistic proposition?
That's a really good question. Jean-Pascal?
It is one of the biggest potential in front of us. So it's not yet available at scale, but a car works only 10% of its time. The rest of its time, it's parked, right? Then the system of energy is producing energy which is not used at midday, for instance, in many countries. You can charge all those batteries and reuse them at night, of course, with the consent, as you said. And this creates tons, thousands of virtual power plants that you can call in substitution of a traditional power plant. You can do two things. You can shut off the consumption. That means you can send a digital signal which says, you want it to consume, can you delay? That's one thing. And at the same time, you can call on the battery of people who want to produce energy. That is what is going to happen because we are developing every aspect of the value chain to make it work.
And this is exactly where the communications network comes in, because we need a system that manages this virtual power plant, which is a very good term, because it is a system that combines demand variations, production variations through renewables, and then batteries, and manages that whole thing in real time digital. In addition to car batteries, there's a lot of other storage also in the system that can be connected. There's more and more home batteries, there are industrial storage facilities, and actually the telecommunications network is also a storage vehicle, because there's a lot of backup batteries, for example, in mobile base station sites, and all these can be digitally connected in the future.
Fascinating. Did I see any other hands here? I can keep going otherwise. Okay, in which case. And if you do, just raise your hand, I'll bring you in later. Christoph and Katharina, I wanted to come to you with, again, leaning into optimism. Where are the biggest opportunities that governments and companies are currently not thinking about? So as you look down 10, 20 years from now, what gives you the most excitement? Let's go Katharina first, and then Christoph.
Thinking about digital and the energy system, I personally think the most exciting chance we have with digital right now is actually driving the decarbonization of the system. And that is partly via transparency and efficiency gains, but it's partly via real technology innovation, where processes that in our days emit a lot of carbon can be substituted by technical, digital-driven solutions that do not emit anything. And for example, if you look at the oil and gas industry, the main sources of emissions are actually methane and flaring. And I think both of these problems can be tackled via digital solutions. And I think from my perspective, that is the biggest gain that I see, and the most essential one to me.
And what's the holdup there? Why doesn't it happen faster?
Why doesn't it happen faster? So first of all, it takes time to get technologies that are certified and where you can really show how they bring emissions down. It's a comparably long process, first of innovation, then on certifying, and then on bringing customers on board to really utilize them and drive them. But I think, honestly, from my perspective, it doesn't even take that much time. It's just that we didn't start like 10 years ago, but that the process started, whatever, a couple of years ago, 3 years ago, 4 years ago. And if you look at the progress we've made in this comparably short time, I would say that's enormous, how carbon intensity went down in the energy arena in different sectors. So I wouldn't even say it's that slow. It could be faster if the world would be less fragmented and if partnerships would be established faster. But on the other hand side, I think we are on a pretty fast pace. So
Christoph.
That's why I have very high hopes that we will be able to really decarbonize major parts of the energy system in a comparably short time.
You and the rest of the world. Christoph.
So I have a very short answer, and that is essentially the answer that Jean-Pascal gave at the beginning. I mean, work on the demand side and get consumption down. I mean, that's the most immediate short-term opportunity. It's not trivial, but I think evidently it would be hugely helpful to get the world in balance on energy in general. Why is it not happening? Well, if you're in a democratic country, the fastest way to lose in the polls and to lose votes in the next election is to tell people how they have to consume energy. I think that's now a proven pattern in many parts of the world. It's, I mean, every politician hates it. I mean, no matter where you are. And look, ultimately, you can now blame the politician. You should blame the consumer and the population that they just are not open as much as we maybe all should be, right? And so I think I would like to see more creativity and boldness actually on the consumption and demand side.
All right, fascinating. We'll leave it there. Thank you very much to our fantastic guests. I'm just going to call out their names one last time. Christoph Schweizer, CEO of BCG, Katharina Beumelburg from SLB, Jean-Pascal Tricoire from Schneider Electric, and Pekka Lundmark from Nokia. Thank you so much for your insights and your candor. Thank you also to our audience.
Thank you, Ravi.